Hey guys, welcome back to the What Comes to Mind series. My hair is grown a bit, as you can see. It has rained, so I'm crouching. But there's another episode 27, and we're talking about COVID-19 treatments. What options are there? What can we understand? What is the misconceptions? So we're all armed with those basic information that we need when we are searching through the interweb. Right, shall we get started? So let's start with the first one, which is antivirals, antiviral medications. Now, we may assume because it says antiviral, we think that potentially it kills or it destroys a virus. But it's not actually the case. What actually happens is that these antiviral medications actually inhibit the virus actually replicating. Now, to understand why is that really important, we need to understand what the virus actually does. One of the main key information regarding viruses is that it hijacks our own cell, it gets into our own cell and starts to use our own machinery inside our cell to make its own copies of itself and also make certain molecules that's going to help its survival. Now, the way these antiviral medications work is that within our cell we have, you can say, biological catalysts. So we have many reactions going on in our cells to make certain molecules that are really important. So there's something called enzymes. These are essentially a biological catalyst to help increase or drive that reaction faster. So enzymes and certain protein enzymes are really important for viruses to make the molecules it needs in order to grow, survive, replicate, and do all of those kind of businesses. These medications try and inhibit, predominantly, not all, but most of these medications, antiviral medications, actually inhibit those particular biological catalysts, those particular enzymes, to stop viruses actually replicating high enough to cause a huge, massive problem. So in theory, the notion is that once you have maybe successfully inhibited viral replication, the level and the volume of viruses around the body is relatively low compared to without the medication. So the immune system can really work on trying to get rid of the actual virus. And as I mentioned earlier, these antiviral medications don't necessarily kill the virus, they just stop its actual replication. Obviously, I know you don't follow me whilst I'm doing these videos, but I always wanted to show you that. I hope I do have it in frame, but sometimes just standing, I'm actually going to show you what I see. Sometimes you don't need to talk, you just need to see. It's a beautiful thing that I get to walk past every day. But shall we go on to the next one? I think so. Now, the next one in terms of COVID-19 treatment is looking at immunosuppressants. Now, they won't do nothing to the virus itself, but it's the effects the actual disease causes is where these immunosuppressants come in handy. Now, you're probably wondering, hey Amir, how does that make sense? We need the immune system to fight off the virus, and you're telling me we take drugs to suppress our immune system and inhibit it. And unfortunately, that is the case, and here's the actual reason why. It's something I mentioned back in episode 5 of this series, which you could see here hopefully, on inflammation. It's the notion that when something like a bacteria or a virus comes in, it triggers our you could say immune system to go into super hyperdrive, where there's excessive chronic inflammation that becomes a detriment to our body. So we know that inflammation is useful in terms of a physiological process, but the virus causes our body to go into kind of overreaction, a hypersensitivity reaction towards, in a sense, COVID-19 at the moment, where the excessive inflammation starts to damage the body. So this is actually where immunosuppressants come in handy, and you might have seen on the news in the notion of something known as dexamethasone. I'll put the name here, and you've seen that, oh, this is gathered a lot of promise because this is a steroid, a very cheap steroid that has been shown in certain cases, in certain situations, to actually minimize the unfortunate effects this COVID-19 strain causes on the body. And how does it work, as I mentioned earlier, is in low doses, this steroid can suppress the excessive abnormal inflammation that occurs from having been infected with a virus. So that's where you can minimize the damage caused to the body, but not too much where it suppresses the immune system so much that we can't actually fight off the virus. And that's where it gets a bit tricky with immunosuppressants, because you want to balance the notion of limit the amount of excessive inflammation that damages the body, but not too much where we don't have enough of the immune system to fight off the virus. So that's why it's quite often mentioned low doses and in certain situations. Where if I put it in the articles below, where they looked at in hospitalised patients, so people who may be on ventilators, where the damage is quite severe, so you're trying to suppress any excess damage from the virus and giving the body enough of the immune system to try and get rid of the COVID-19 virus. You can just see that every time I talk about anything immunology related, I can talk for hours. I can literally talk for hours. So I try to keep this next one a bit shorter, so I don't lose you guys during this video. Next one is plasma therapy. Now you might have heard this because UK Prime Minister Boris Johnson, who unfortunately contracted the virus, successfully recovered by having a form of plasma therapy. You might forgive me for this, but you just gotta look at. I think you would forgive me for stopping the video to look at that. There's so many. So what I'm hoping to do in each of these videos is to show you a different flower, a different part of this very beautiful park. But back to plasma therapy. When somebody contracts the virus, the immune system starts to function and work to try and produce molecules known as antibodies to try and basically counteract the virus, try to bind to it to get rid of it, etc. Now if somebody unfortunately has the virus and then recovers, they've produced the correct and specific antibody that binds to this particular virus to try and get rid of it. So they have, you can say, the special, you can say, fighters in their body. So what this plasma therapy is that they extract those antibodies from the plasma, which is in our blood, in the patient who has recovered from the coronavirus, and they give that plasma to a person who has just contracted the virus. So you're kind of like reinforcing the person's immune system with those fighters from somebody else who successfully recovered. So that's actually how this plasma therapy works, and it's really effective because you're essentially arming your current, if you were to, unfortunately, I hope you don't, but if somebody was to get the COVID-19 strain and the virus, you're arming it with the pre-selected fighters that are required to get rid of that virus or to actually fight that virus. But the unfortunate thing is that you need a lot of the plasma from the person to make sure that it is effective enough to try and beat off the virus. So, and you got the whole notion of, you know, matching patients in terms of blood profile perhaps. So it's great, you know, it's as actual therapy, but as a large scale kind of fight against COVID, it's not as feasible. But I do think as more and more patients recover, thankfully, from the actual virus, we may have more and more plasma therapy and the actual plasma available to try and treat those patients who are in a difficult situation where, as a last resort, the antivirals are not working, the immunosuppressants are not working, and we need to look at another form to try and save those patients. So I do think, hopefully, around the world, that they'll be recuperating a lot of plasma from those people who have actually survived, thankfully, and hopefully can use their blood to help somebody else, which I hope can continue and expand and develop. The next one is more of a targeted approach, something known as monoclonal antibodies. I mentioned antibodies earlier, and it's the specific molecules our immune system generates to fight off something that's foreign or something that's harmful. Now, this notion of monoclonal antibodies has been around to treat forms of severe asthma, so certain molecules that trigger airway inflammation for asthma, some forms of cancer. This type of therapy is utilized, and the way it works essentially is these antibodies are generated by sensitizing or triggering a production in potentially a mouse or a rat in that sense, and then they're able to extract those particular antibodies from there. It's also done actually in vitro cells, what we mean cells that we grow in the laboratory, and we can actually generate antibodies from them and then put them together, purify them, and we can give them to a patient to kind of bind to a potential protein that is harmful. Now, the way this works for this particular context is on COVID-19 strain, so on the virus itself, there are certain proteins known as spike proteins on the virus itself that binds to the host cell, something known as cell adhesion. It actually binds to the cell. If you can figure out a way to have a molecule that binds to this spike protein on the virus and stops it from binding to the host cell, you in effect stop the virus invading the cell to start replicating and cause a problem. That's why there's a lot of research, which I'll put some kind of articles in the description box below about synthesizing these monoclonal antibodies to bind to these proteins on the actual virus to prevent it from binding to the host cell. And that's where this is actually gathered a lot of interest, and rightly so, in terms of trying to treat this particular virus. So this last type is something we've heard about in the news, something we are anticipating and looking forward to, and something researchers around the world are working non-stop to try and produce, and that is vaccines. Now, before I go into vaccines in a bit more detail, for those of you who don't know how a vaccine actually works, here's a little bit of a breakdown for you. Now, essentially the way it works is you are given a form of the virus or bacteria in question, but something's been added or altered or changed, so you don't elicit all of the actual issues if you were to get the full-blown version of that condition. So in this case, it's a virus, so you may receive in the vaccine form of the virus, the whole virus, but something's been altered, an inactive form of the virus. So essentially you are priming your immune system to recognize the virus that's coming in, produce those particular antibodies as I've talked about throughout the episode. So if you were to get the full-blown condition, you're a lot more prepared, your body's a lot more prepared, and your immune system is a lot more prepared to try and combat that virus a lot quicker if you were not to be vaccinated. Now, the reason why it's different to plasma therapy is with plasma therapy, as I mentioned earlier, you are given those pre-selected antibodies from somebody else's blood who's recovered from the virus. Whereas a vaccine, you're essentially trying to produce those antibodies yourself without actually having the full-blown condition. Now, you might have heard on the news, you might have heard from colleagues, friends, family about certain concerns over vaccines. And this has come from certain issues in the past related to particular vaccines and how the actual vaccine is preserved in the actual vial. I'm here to just give you a bit of information about where that came from and how that's not so much an issue now than it was before. Now, the issue arose from certain preservatives that were used in childhood vaccines during the late 90s. And these preservatives were in the form of chemicals that contained heavy metals, in particular mercury. Now, the reason why it was actually used is that some vaccines back then, and even in some cases now, are given as a multi-dose vial. It comes in a multi-dose vial where you can give it to multiple patients without having to get a new vial out. And once you inject it into a patient and that needle goes back in, there is a chance that the needle can get contaminated when it goes back in and potentially contaminate the vaccine. So certain preservatives, for example, something known as thimerosal, which you can see here, was used, and it's not really used much now, as a preservative to try and combat that issue. So that's essentially why you can say the heavy metals were used to prevent infections in the actual vaccine itself. Now, this thimerosal mercury containing preservative gathers a lot of negative press during the late 90s because of certain links towards developing higher forms of autism in children. Now, there are many articles opposing this, which I'll put in the description below. And even though people have still concerns over it, in 1999, the UK kind of agency for looking after this removed thimerosal as a preservative for all childhood vaccines. And many other vaccines didn't actually have this additive in the first place, even though many people actually thought so. And largely because of that preservative, vaccines got negative press, and it's still concern for many parents and many personnel who are concerned about taking a vaccine. But to help shed light on the potential pros and why people should consider taking vaccines is, even now with the whole flu vaccine, there are preservative-free and preservative forms of the vaccine. So you can have a single dose vial, which doesn't have any preservatives in, which really minimizes any potential side effects you're going to get from a vaccine. Yes, you might have some redness, some swelling. You may develop mild symptoms of the virus because remember, you are being injected with a form of the virus. So you may encounter some symptoms. But the whole notion of thimerosal and these heavy metal preservatives has been drastically reduced and removed from all forms of vaccines generally. And all childhood vaccines don't have thimerosal now. Here's some evidence in the description box below. And even adult vaccines have the option, as I just mentioned, of preservative-free vaccines. What I feel we should be slightly more concerned about is who the vaccine is given to and if it's been fully developed yet. Because of the fast-track nature at the moment, because the pandemic is still around and still causing a lot of problems around the world, the research is being accelerated. And the issue is that some vaccines cause more harm than good depending on who actually takes it. Now, to give you an idea, so let's take somebody who has severe asthma, for example. We know that when somebody has that form of disease and the virus comes around, it's a very, very deadly combination that elicits all sorts of immune responses that cause a real detriment to that person's health. And in some cases, even when they are given a vaccine which contains the virus that has been altered, that has been mutated and been made defective, it can still elicit such a powerful immune response that still causes harm for those patients. So that's why it's also really important to remember that a vaccine is not going to be a universal savior for everybody, because there are still some patients who may not be able to take it. Even to add, many personnel who actually have certain conditions require a lot of medication, a lot of immunosuppressants that really suppress the immune system. And the whole notion how our vaccines work is you need the immune system to generate those antibodies from the vaccine that's coming in. And if you are severely immunocompromised because of a condition and because of certain medications you're taking, that can be a huge problem to produce those antibodies, because your immune system is unfortunately not strong enough to do that. And it's also not potentially strong enough to fight off the vaccinated version of the virus that's been altered or mutated. So that's why I do feel that a vaccine is going to help save a lot of lives, 100%, but it's not to be confused with a complete cure against COVID-19. I think lastly to add, there are now many forms of this particular strain of the virus. And even though certain vaccines can account for different strains, just because you've taken the vaccine that's hopefully going to be produced soon, doesn't mean that you're completely free from potentially getting COVID-19 and even being fully protected against it. Because unfortunately, it could be the case that there are other strains of the virus that are not incorporated in the vaccine yet. So even though it's going to be a huge promise, a huge help in the fight against the pandemic, it's not to be confused with a complete cure that's going to completely eradicate the virus. Because if that was the case, vaccines for the flu would have completely cured flu for decades. But unfortunately, we still have to have yearly vaccines because there are different strains of the flu, and we hope that there are not going to be too many different strains of this particular virus, this COVID-19 strain. So if you did enjoy the video as well, do like and comment if you can. If you were able to hit that, I think it's called subscribe button, if you were able to hit that, that would be really great for the channel and myself. And I look forward to seeing you in the next episode 28. We are 28, 29, 3 away from the 30 mark that I already set out. Getting closer, aren't we? Hope you have a good day, stay safe, and I'll see you soon.